Hello everyone, this is Miss Chelsea and today we'll be learning about moles and formula mass. Our question of the day is to brainstorm how do chemists measure things they cannot see? Our standard of the day is SC3C, which is to use mathematics and computational thinking to apply concepts of the mole and Avogadro's number to conceptualize and calculate present composition, empirical/molecular formulas, mass, moles, and molecules relationship, as well as the molar volume of gases. To do so, we need to know what is a mole. A mole is a group of atoms bundled together so that chemists can work with them. The number of atoms of carbon in 12 grams of carbon-12 is a mole. Notice how the atomic mass on the periodic table is the mass of 1 mole of that element. So, how do chemists measure things they can't see? They lump them into groups that they can see called moles. If an atom is like a grain of sand, a mole is like a sandcastle mold. The grains of sand are bundled into larger groups of a predictable size. Then we can count the number of molds instead of the grains of sand. A lot easier and a lot less work. Mole is just a name for a number, 6.02 times 10 to the 23rd. This number is called Avogadro's number. Each element has its own mass. Because all moles are the same quantity, we can use moles in place of molecules, and each mole will have its own mass. A mole of elephants would be heavier than a mole of butterflies, for instance. The same will apply for a mole of atoms of different elements. In order to find the mass of a mole of a molecule, however, you will need to add the individual masses of the moles of elements. So let's look at an example, KMnO4. So in this example, you have 1 potassium, 1 manganese, and 4 oxygens. We count the number of atoms in the molecule. That means that we will have 1 mole of potassium, 1 mole of manganese, and 4 moles of oxygen atoms in 1 mole of KMnO4. Then we find the masses from the periodic table. So we would have 39 grams of potassium, 55 grams of manganese, and 16 grams of oxygen per each mole. But to find the total mass, we would need to multiply the number of moles by the mass of a mole. So 1 times 39 gives us a total of 39 grams of potassium, 1 times 55 is a total of 55 grams of manganese, and 4 times 16 is a total of 64 grams of oxygen. When we put all that together, we end up with 158 grams of KMnO4. This means that 1 mole of potassium permanganate has a mass of 158 grams. When the balance reads 158 grams, you know that you have 6.02 times 10 to the 23rd particles, or a mole.